Hello all, welcome back to another episode of Mr. Hawkins' geometry class. Hopefully you enjoyed the opening video which I made and produced. But in any event, these are the notes portion of this. Again, we talked about an inscribed angle and what that meant. The objective for the day is to be able to identify and use properties of inscribed angles. So down here I have a picture of a circle, and again I introduced the concept of a inscribed angle by using a central angle. So remember that a central angle is basically the angle between two radii. Angle between two radii. So if I have one radius like this from the center, that would be a central angle. So now I introduced a inscribed angle. So central angle has an angle at the center, and inscribed angle has an angle on the circle. It's the angle between two chords. Where the intersection is on the circle. So I'm going to have my inscribed angle right here. So this is my inscribed angle right there. So now I also talked about the intercepted arc. Remember Joey was the intercepted arc? This is the arc made by an angle. So this would be the intercepted arc right here. Not sure why they call it intercepted. So again, the green one is your inscribed angle. The blue is your central angle. And then that is the intercepted arc made by both of them. And again, we kind of described the inscribed angle theorem by using Joey and his example on the kitchen floor. But basically you notice that this angle here, the inscribed angle, is smaller than the blue central angle right there. And it's smaller by exactly half. So the inscribed angle theorem is an inscribed angle is half of the arc it makes. Or you could think of it as the arc, the intercepted arc, is twice the inscribed angle. Depends about your point of view. So that's what we're going to use today. Here is the inscribed angle theorem written out formally with a picture. But again, you notice the inscribed angle here is at 61 degrees. It is exactly half of the intercepted arc at 122 degrees. So the angle is half of the arc. All right, so there are important corollaries. Corollaries, if you remember, this is kind of a spin-off of a theorem. So this is true as the result of the theorem. This one says if two inscribed angles intercept the same arc, then they're going to be what? So I'll draw one inscribed angle, and then I'll draw a second inscribed angle that makes the same arc. since they're making the same arc, they're both going to have to be half of whatever this is. So whatever that is, say it's 50 degrees, that means each of these has to be the same 25. So two inscribed angles that make the same arc are always congruent. Another spin-off of that is an inscribed angle of a semicircle. So if I have a semicircle, and I can indicate that by this, and now I have an inscribed angle that makes that semicircle. Well, semicircles are always all the same measure. They're always 180 degrees. So that means if an inscribed angle is making a 180 degree arc, the angle has to be half of that, or 90 degrees. So an angle inscribed in a semicircle is a right angle. And then the last corollary deals with opposite angles of an inscribed quadrilateral. Inscribed quadrilateral has to have vertices on the circle. So I'll draw one like this. So now if you think about this, you can look at it as two pair of, I probably should have drawn like this a different color. So now this green inscribed angle is making this portion of the circle. This blue inscribed angle is making the rest of the circle. That means they make 360 degrees in arc. Well, the angles then are going to have to be half of that, or 180, which means that opposite angles of a quadrilateral in a circle are always going to be supplementary. They're going to add to 180 degrees. That's because their arcs are making the whole circle at 360 degrees. So let's see what kind of problems I can grade you on here. So down here, a list of examples here. Number one, I don't know if it's complete, but basically what I see is I see a couple inscribed angles that make the same arc. So I see this angle BAC, and I see this arc here BDC. They make this same arc BC. So because of that, these two have to be congruent to each other. Looks like number two, they want me to find the value of x on this one. So this one does have some information on it. So now what you need to do here is you need to remember the relationship between a tangent and a radius. Tangent and a radius, if you remember, are always perpendicular. So that means x is equal to 90 here. Y is a arc right here. Its inscribed angle here is 35, so it has to be double that. So that means y must equal 70 on that one, which is 35 times 2. Over here, it wants me to find the values of A, B, and C. I do have some information here that the inscribed angle is at 25 degrees. So it's making this arc A, which is what I'm looking for. So it has to be twice that. So A is going to be 50 degrees. B, you'll notice, makes a semicircle. Semicircles are always 180 degrees. So it has to be half of that, which means B has to be 90 degrees. Notice that C also makes the same semicircle, so it is also going to be 90 degrees. So that's how you do that one. Number two, or this part down here says for each diagram indicate a pair of congruent inscribed angles. That's the same diagram as up there. I would say angle A is congruent to angle D. I also see that angle B would be congruent to angle C because they both make AD. Down here, indicate a pair of congruent inscribed angles. So again, this inscribed angle, so these chords are congruent. So congruent chords also make congruent arcs. So these arcs would be congruent. Since they make congruent arcs, these angles here would have to be the same. So I would say that angle ADB is congruent to angle CDB. Over here, a pair of congruent inscribed angles. So I see one inscribed angle right here, ADB. I don't see any other inscribed angle making that. I see another inscribed angle here. Oh, I have vertical angles here at the center. These are congruent central angles. So that means what? This arc has to be congruent to this arc because these vertical angles here. So now I have to look for inscribed angles that make those arcs. Well, here's one inscribed angle that makes that arc. So that means angle ADB is congruent to, again, if I look at for this arc here, I see an inscribed angle here at A or DAC. So that's a pair of congruent inscribed angles on that one. Let's see, more example problems here. This is a simple example of an inscribed angle. Its intercepted arc is that 110 degree angle. So I just take half of that. That would have to be half of that, which is 55 degrees. Down here on this one, I have 2 out of 3 arcs of the whole circle. So again, 170 plus 90. That's 260. So since these two add up to 260, this third angle must be 100. So it all adds up to 360 degrees. So now I could use some inscribed angles here. X is across, we're making a 90 degree arc. So because of that, I know X is going to be half of 90, which is 45. Let's see, Y is an inscribed angle making 100 degrees, so that's going to be 50 degrees. Z is making a 170 degree arc, so what is that, 85 degrees? So basically I'm just using these properties of inscribed angles. 6, I think we already did on the previous page. This one, number 7, I see this inscribed angle here is making that arc. To figure out what that is, I need to figure out what the inscribed angle is. Again, all the angles of a triangle have to add up to 180. So I'll find this inscribed angle and then just double it. So let's see, 62, 28, so that's 10, so that's 90. So that means this third angle has to be 90 degrees because I have to add up to 180. Then this is a 90 degree angle, so that means this must be a semicircle. So X must be 180 degrees. Over here, notice I have a tangent. This is not a radius. I got part of the circle is 220. I can figure out what the other part of the circle is by doing 360 minus 220. So do 360 the whole circle minus out that 220. So that would be 0, 4, 140. So this is a 140 degree arc. So now when you have a tangent and a chord like this, it still has an intercepted arc. The intercepted arc would be right here. And that's 140 degrees. This is going to behave just like an inscribed angle. You're still going to take half. So you're going to take half. X would have to equal 70 on this one. This one often confuses kids, so I'd keep an eye out for that. So if you have a tangent and a chord like that, you still take half of the arc, just like an inscribed angle. Down here on number 9, here I see part of the circle is 240. Again, I do 360 minus that. 360 minus 240. So that is what, 120? So that's a 120 degree arc right here, which was Y. So it's a 120 degree arc. So let's see. X is a central angle that makes that 120 degree arc. So remember, central angles and their arcs are the same. And then I got Z again. So that's a tangent and a chord here. So again, it's going to be half of the arc it makes, which is 120. So that's going to be Z is equal to 60. Number 10 down here. Again, I'm going to double the inscribed angle. This would have to be 100. Double the inscribed angle. This would have to be 140. They all have to add up to 160, so they're 240. So I do 360 minus the 240, and that's 120. Again, I have a tangent here. I have an isosceles triangle. I notice that it's isosceles. So again, I do 180 minus 54. So that would be 126. And then I'm going to divide that by 2 because these base angles have to be the same. So that's what, 63. So Y is equal to 63. So now I can figure out using this inscribed angle that this arc right here is going to be double that at 108. All right. These have to be congruent because of these congruent chords. So I do 360 minus 108 divided by 2. All right, so the rest of the answers are right here. So you can check your answers on that. The completed notes are also posted. You can look at those as well.